Turning industrial waste into something useful is at the heart of a revolutionary international project sponsored by the Newton Bhabha Fund. Scientists in the UK and India have come together to take a major byproduct of the sugarcane industry and turn it into the valuable chemical citric acid. As the second largest producer in the world, this waste poses a particular problem to the sugar industry in India.
It generates an awful lot of byproduct, which is called bagasse. Bagasse is basically a fibrous material, a biomass. Currently, the biomass is used by the sugar factories as the fuel to produce electricity and steam that is then used to power the sugar factory to produce the sugar. Now, the biggest problem with this is it's the most inefficient use of the bagasse. So that's the biggest issue sugar factories face right now, which is there's no other alternative for bagasse rather than just burn it.
To solve this problem, a collaboration of UK and Indian researchers have worked together to develop a new process to turn the sugarcane bagasse into something more useful. The first step is to pre-treat the waste by warming it and adding a dilute alkaline solution. This process breaks down the fibrous structure of the bagasse, making it easier for chemicals to interact with it. Next, specific enzymes are added which break down the bagasse into a mixture rich in sugars. This sugary mixture then has a fungus known as aspergillus added to it. The fungus feeds on the sugar, turning it into citric acid, a chemical with many different uses.
This finds uses in a number of different sectors, the food, pharmaceutical, cosmetics and so on. Because it's generally regarded as safe as a material to eat, it can also provide pH buffering and effervescence and so on, as well as acting as a preservative.
In the lab, the process has been shown to work, but what about its applications in the real world?
The issue is that we've still only done that at small scale, and in order to really assess the economic potential of this and the potential for investment, we need to do it at a considerably larger scale. So the next step is to try and raise some funds to do pilot processing trials, probably at about 100 litre scale. And if that all goes well, then Natems are very interested in building a factory to run this process, which would be the first of its kind in the world in India.
Once we've finished the project, we want to then take it to the next step where we will do a pilot project, and then we want to then roll it out across on a commercial basis. But as it stands from the data that we have seen, it looks very promising, very, very promising, and commercially it should be quite viable. So it's quite exciting.